Hello everyone, welcome back to Through Deviations. Substitution is a really nice tool that allows us to anti-differentiate a lot of functions. But integration is really, it's most helpful when we can do it definitely. Now for substitution, we have a kind of interesting rule that we're not going to really see with many other anti-differentiation techniques. And it's going to make the definite integration with substitution a little bit more tricky. So why don't we talk about how we can deal with these definite substitution integrals. So we're going to have a theorem statement that tells us how to deal with it. So first, we're going to talk about the setup. So we need to make sure that our function g is continuous, that f is continuous when we are setting g of x equal to u. All right, so if you remember, the statement for the substitution rule is the integral, there's a bad integral sign, the integral of f of g of x times g prime of x is dx is equal to the integral of f of u du. You've seen that plenty of times, I'm sure. So now that we know that our function g is continuous and our function f is continuous on our given interval, then we can say that if I want to take the definite integral from a to b of f of g of x times g prime of x dx, then that's going to be equal to the integral from g of a to g of b of f of u du. All right. So what this is basically saying is it says we need to change our bounds if we're going to change our variables, if we want to solve this easily. So there are basically two methods that we can deal with it. The first is that when I take my function and I transfer to u, when I transfer to u, I'm not going to need to change my I'm going to need to change my bounds so that I get a numeric answer just in the u variable. However, my other option is after I've found the antiderivative and I want to switch back to x from u, then I won't need to change my bounds. And then I could just proceed with the fundamental theorem of calculus. But the first method is a lot easier because it saves us from jumping back to x afterwards. So why don't we try an example where we deal with that. So we're going to take an elementary antiderivative, and then we are going to take its definite integral. So we're going to take the integral between 1 and 5 of the square root of 3x plus 1 dx. So to do this, we're going to start off pretty normally. We are going to make our bracket. We are going to set up our reverse chain rule. So as you can see, I have a 3x plus 1 in the integrand. But what's nice about this is if I take the derivative of 3x plus 1, that's going to be equal to 3. And that's a constant term, and we can manipulate that. So we're left with if we take u equals the square root of 3x plus 1, then that will leave us with the square root of u. Then we just need to deal with dx. Now dx is going to be equal to 1/3 du, which is just a little bit of manipulation. So now we can deal with manipulating our bounds. So to manipulate our bounds, basically what we do is we take this formula here and we plug in 1 for x and then 5 for x, and then what we get out as u is going to be our new integration bound. So let's start with 1. So we'll start with the lower bound so we can determine what we are going to be putting in our new integral with respect to u. So if I plug in 1, we'll get 3 times 1 plus 1. So 3 times 1 is 3, plus 1 is 4. So we get 4 as our lower bound. Now we'll do it with our upper bound. We'll do it with 5. So we'll do 3 times 5, which is 15, plus 1 is 16. So now we have 16 up here. So now we have our two bounds. Now we're ready. Now we have mapped our bounds into our u domain. So now we'll be left with the integral, or 1/3 times the integral of from 4 to 16 of the square root of u du. Of course, then that means that we get 1/3 times 2/3 u to the 3/2 evaluated between 4 and 16. The rest is just simple algebra, and that leaves us with 1/3 times 112 over 3, which is equal to 112 over 9. All right, thanks for watching our video on how to deal with definite integrals and the substitution rule. So we'll be talking a little bit more about this in the in the next video, sorry. And after that, we will be moving on to Unit 5. All right, thank you for watching. We'll see you guys to talk about some more definite substitutions.